So now, this week, we are going to look at two-dimensional kinematics. Now, this is a specific type of motion. This happens kind of any time that you throw things on Earth or launch things. Everything will show this type of motion. Now, this is a very specific shape. You might have kind of studied this shape in math, but that's called a parabola. So this is parabolic motion, or in physics, we call it projectile motion, because any projectile is going to show this similar path when it's launched. Now, there are a couple parts kind of when it comes to this type of motion, and you can probably even see that in this diagram. If we look at this ball that's being thrown, you'll notice that there's the same horizontal distance between each of these moments in time. So this is kind of a bunch of different pictures. But you'll notice that as you go horizontally, so just in this horizontal direction, the distance between these doesn't change, right? If we were to think about it as a graph, right, in that horizontal direction, the distance isn't changing, or the distance is changing, but it's increasing at a very specific rate per unit time. And we know that these types of graphs are for uniform motion. So in this horizontal direction, it's actually traveling at the same speed all the time. Now, there are things like wind resistance and stuff like that that would change it. But ignoring wind resistance and friction, which is usually pretty small, we have uniform motion in that one component. Now, the other thing you'll notice that if we look at this vertical component and we were to look at the motion in that direction, you'll notice that the space between these lines is not the same. Right? As we go up, so as we go up here, so we go up, 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 you'll notice that these lines are getting closer and closer and closer together. And that should make sense because we know that if things are going up and down, gravity is acting on them. So like this thing has an initial velocity, but then that velocity is eventually going to zero at the top. And then as it comes back down, maybe it will increase again. It will accelerate on the way back down. Just like when something's going up and down, it has accelerated motion. And this is really the big idea with projectile motion, is that a projectile has kind of two different components to its motion. There's the horizontal component, which is uniform, and then there's the vertical component, which is undergoing acceleration because of gravity. So again, if we were to draw vectors for this horizontal motion for any projectile, the velocity vector in the x direction should always be the same. Because in this horizontal direction, it is undergoing uniform motion. It's not speeding up or slowing down. Whatever initial horizontal velocity I impart on that projectile, it's going to have that same initial horizontal velocity at the end. Now the y one is different. Now initially this has an upwards velocity, but because gravity is acting on it, it's slowing down to the point where at its maximum height, the y velocity is 0, and then it starts accelerating downwards towards the ground again. So if we were to draw this as a velocity time graph, it's initially positive, then it maybe reaches 0, and then it's going to be increasing in the negative direction, so it probably goes something like that. And we know that the slope of this is the acceleration. The acceleration of this object in that direction is 9.81 meters per second squared. Now, because these components undergo different types of motion, it is important to understand that we use different formulas to analyze these different directions. So in the horizontal direction, because it's uniform, we use just a very simple uniform motion formula. And that's only for uniform motion. One thing I did notice on our 1D exam is we're mixing kind of horizontal and vertical type formulas. Like we're mixing uniform kinematics with non-uniform kinematics, and they really are separate. So when I'm looking at this horizontal component, I am using just velocity as distance over time. When I'm looking at this vertical component, because it's accelerated, I'm using my kinematics equations. So I'm using like VI, I'm using my acceleration, the distance. I'm using all of these different variables when I'm looking at this vertical component. So it is important to understand that we have different sets of formulas for this horizontal and for this vertical component because they're undergoing different types of motion. The other big idea, and this is kind of what allows us to be successful in these types of questions, is that the time component is the same in both of these dimensions. This is still one object undergoing this parabolic type motion. So the time it takes for it to go up and down is the same as the time it takes to travel horizontally in that direction. It still hits the ground at this point in time. And that's the same for the horizontal and the same for the vertical motion. So that's kind of the big idea, and that's usually what's used to link these two parts, is that this time is the same in both of those dimensions. So time is the only quantity shared between both dimensions. The distance covered in x and y, velocity in x and y, and acceleration in x and y are all different, but time will still be the same. Now, there are some different types of projectile motion. Like, there's not really a general rule, but we can have some different shapes. Like, we can have people or things like kind of going off a building. So there's a guy. We can have kind of this type of projectile motion. Or we can have someone maybe throwing something, and we have this type of projectile motion. Those are probably the two main types, where this one we have an initial velocity going up and an initial velocity going down. This one we only have an initial x velocity. So there are kind of some important differences between those. When we're talking about this type of motion, my initial y velocity is 0, whereas when we're talking about the throwing type, my initial y velocity is whatever that component is, and my final y velocity is whatever that component is. And then if I'm asked for things like maximum height, my y velocity here is 0, just like if we were throwing something straight up and down. Now, other things to note with kind of these types of questions is maybe initially my y velocity is positive. At the end, it's going to have the exact same value, but it will be negative. It'll be in the opposite direction. My x component will always be the same, right? At all of these different points in time, my x velocity is the same. It's not changing. Just like in this one when we're running off, my x velocity at the end is still here, but now my y velocity went from 0 to being whatever it is downwards at the end. So here's a question. So we have a bird. It notices a piggy's base and launches at it. So the bird is launched at an angle towards the horizon. So its initial, it gives us some information about its initial velocity. It wants to find the launch angle, time in the air, range, and initial velocity. So we have a lot of questions kind of to answer here, and a lot of different ways to get at it. So the first one, let's look at A first. So it asks for the launch angle relative to the ground. Now, to find that launch angle relative to the ground, it does give us some components. So it gives us the initial vertical component and the initial horizontal component of that bird's velocity. So we have an initial vertical component here of 19 meters per second and an initial horizontal component here of 11 meters per second. Now we know that when we add vectors together, we add them tip to tail. This is where the bird is actually going, is that direction, right? It's actually a combination of both of those components, the horizontal and the vertical component. So when we answer this question now. So let's look at this. We have our two legs here, and we really just want to find this angle. So I can use tangent. So tangent of theta is my opposite side, so 11 over my adjacent side, which is 19. So tan to the -1 of 11 over 19 is 30 degrees. So this is 30 degrees here is that angle. So now it says relative to the ground. So I'm not going to use that 30-degree angle because that's not relative to the ground. The ground is here. So if that is 30 degrees, that means relative to the ground, it should be 70 degrees. No, I am bad at math. Should not be 70 degrees. Relative to the ground, it should be 60 degrees. So it's 60 degrees relative to the ground is the answer in A. Then we have some other B, C, and D. Maybe we'll answer D right away because we're basically there already. It says initial velocity. Now, I have two components of its initial velocity, but its initial velocity is this whole leg. So we do know the angle. Let's just find the initial velocity. So now I'll use Pythagorean's theorem. So c squared, my longest side, is equal to a squared plus b squared. C is the square root of both of those, a squared plus b squared. So the square root, so I have 11 squared plus I have 19 squared. And then the square root of that is 21.9, or I guess 22. So 22 meters per second. And then I guess we have that angle from A, 60 degrees above the horizontal. So again, we just used kind of those two components to find that initial velocity. So we did D, we did A. Might give you this velocity instead, and we need to first split it into components. This one gave us components, but if we are given something like 45 degrees to the horizontal, we might need to split it up into different components in order to horizontal. B and C now. So usually when we analyze these questions, what I like to do is I like to split it into the X and the Y direction. So we have these two different dimensions. Now there are physics principles that actually are referring to these two different dimensions. There is a net force here. I think that's physics principle 1. So net force is not equal to 0. So if we're dealing with stuff in the Y dimension, that's physics principle number 1. In the X direction, F net is 0. So that's physics principle 0. I think on your assignment this week, it does ask questions about physics principles. And that's kind of what it's referring to. So in the X dimension, because it's uniform motion, there is no net force. In the Y dimension, because there is a net force. So that's not equal to 0. Okay, so we can kind of identify what we know. I'm going to say, so one thing that is important too is determining the direction. So anything to the right, I'll say, and anything up is going to be positive. So I know in my X direction, I know my velocity is 11 meters per second. I know my initial velocity in my Y direction is plus 19 meters per second. I also know my acceleration in the Y direction is negative 9.81 meters per second squared. And the one thing I know, so if I'm trying to find time in the air, so I'm thinking about this type of projectile motion. If I have an initial Y velocity of 19 meters per second, I'm also going to have the same Y velocity at the end, but it'll be 19 meters per second down. So in this question, I do know my final Y velocity. And that's going to be negative 19 meters per second. The other point that's important to note, not for this question, but if it does ask for maximum height, my y velocity at that point is 0. So we do have information about stuff at maximum height as well. Now the thing I want to find, which is important for both dimensions, is the time. This is going to answer question B, but it will also allow me to move and answer question C in the x direction. So the time is the same for both of those. I know that acceleration is Vf minus Vi over t. So my time is my Vf minus my Vi over my acceleration. So minus 19 minus 19, I mean minus 38 divided by negative 9.81 gives me a time of 3.87 seconds. I guess that's assuming that Angry Birds happens on Earth. So that time is 3.87 seconds. That is the same. Now, I guess that answers B. So B's done. That's the time in the air. Now, the important thing is that this is also the time in the x direction. So now I can move that time over here, and that allows me to answer this last question, the range. The range is how far it's traveled in that x direction. I know that in the x direction, it's going to undergo uniform motion, where my velocity is my distance over my time. I know my time. Now I can find the distance in the x direction. So my distance is my velocity times my time. It's 11 times 3.87. And that's 43 meters. There's the range. So that's my answer in C. The range, the horizontal distance is 43 meters. So in summary, when we do analyze these questions, set it up similar to this, where you have your x, your horizontal motion, and your y motion. Your x motion is uniform, your y motion is not. And then write down what we know. This one gave us components. Now sometimes is that question. But once we do that, we treat the y and the x components separately. The only thing that is the same between them is the time. That's kind of a big idea and allows us to jump back and forth. If it's asking range, it's talking about how far in the x. If it's asking maximum height, we're going to where the final y velocity is 0. And all these different things which will allow us to kind of answer these questions. But we treat the x and the y separate. We use uniform motion for the x, kinematics equations, accelerated motion for the y. So this is your assignment for this week. So these are some practice questions in your workbook. And then your assignment this week, you're going to be doing 2 questions just on a separate piece of paper, taking pictures and uploading those pictures. If at any time you have any questions, please post them in the stream. I have had students kind of asking questions just privately. I like the idea of posting them in the stream because then everyone else can see that. And then everyone else can also see that you have questions as well. I think it's important to understand that like this isn't going to be easy for any of us. So seeing that other people have questions, I think will be good for our confidence with kind of what we're doing, because we'll know that we're not alone. And then I can actually respond there, show you kind of much like we did with this question, or like last week with some of those hanging sign questions, how to work through it. And then other people will have that as a resource as well. Stay safe.